Salamun alaikum. How are you? Are you fine? Can you hear me? Yes. Okay. Uh, Thanks. Let me to start the session, the lecture. Uh, I'm waiting for uh, your friends to attend to the class, but we have no time. I should start the lecture soon. So I want to make a record for you, and then let me share my screen. In this lecture, I want to talk about the generalization or specialization. As you know, we have an inheritance hierarchy in our classes. We have general or specialization relationship between classes. So you know we have experience in our ATM case study how to use it in our times. Uh, but in this lecture, as I promised you, we talk more formally about this possibility and the related concepts. Slides. But before I start this lecture, uh, I think it's needed to make a remark about uh, your practice in implementation of ATM. You have sent the implementation of the ATM, but I sent a message for you. The implementation is not acceptable because all of you have implemented a different version of ATM. I think implementation that you have sent for me is copied and paste uh, from each others or downloaded via the net uh, because are the same, and I talk for you enough about I want you to implement this version of ATM. You see, in this version of ATM, we have several classes, but in your implementation, I don't see any of classes except ATM class. Okay, so you should um, prepare a full implementation of this design so that you learn how to uh, implement the classes, how you can uh, implement the reference to other references to as well as implementing the generalization, specialization classes, and how can affect our implementation and so on. So there are several benefits in implementing this case study for you. and your implementations actually are not acceptable for me till now, because none of implementation uh, situation have these features. You goals in this practice. You will learn how to implement your classes, how to connect classes or object to each other, how to call methods of class which are located in a specialization, generalization hierarchy, and so on. Have more attempt, and this is uh, rather complex that the version I want you to implement uh, this design completely with all features that I discussed in your class. Okay. At the end of these slides, you can see some parts of the implement problem with this version of ATM uh, design. So I hope you can send as soon as possible. Uh, Let me see your messages. Uh, Mr. Dalal wrote that can we take the midterm exam after 8? No problem. No problem. We can set a time for midterm. But unfortunately, in previous semester, I have no good experience. Have copied their responses, their solutions from each other students. This type of have no benefit for you. Okay, um, I think you want, if you can, we can have an online interview about the code written, because the written in the meter written midterm you can evaluate uh, Miss Mariam code, but the order of execution remains. I hope you can you make your corrections soon. I only have an variables. Uh, excuse excuse me, Miss Mariam. In implementation, the benefit of implementation is that you can you gain a good experience in debugging. One of the benefits of this uh, is that you attempt to debug your program by yourself. So I hope you make your corrections soon. Okay. Uh, cut for you, Miss Mariam. Uh, other, please tell me your sound cut off or not? Can you hear me clearly? No cutting. Excuse me, let me enter on mic. I come back soon. I'm sorry. Okay. Let me to go to our lecture. Okay, as I told, I'll talk about generalization in more detail in this lecture. As you know, generalization is a relationship between a more general thing and a more specific thing. Um, as I told before, we saw an example about generalization in ATM cases. For example, in ATM case study, we have seen that net transactions of withdrawal, deposit, and balance inquiry, all of the three classes have the same attribute as account number and the same method, execute method. And so that make an to make a generalization type such as a transaction and other classes will be subclasses of this superclass, and we use this type of relationship in our design. The class is a general class and a more general class, and transactions, withdrawal, deposit, and balance query are our special classes in this design. The special classes inherit some attributes and general class, and this type of relationship the redundancy code. As I told before, some of our classes in practice may have some attributes and methods in common. So if we don't use this structure, we have to copy. We have to copy save the same chunk of code in several classes, and the maintenance of this common code is problem for developers. So this structure, this relationship for developers to um eliminate the common code, make see in as a common code of its subclasses. We are familiar with a generalization type, and let me go ahead through this slide to investigate this problem with more detail. The more specific thing is consistent in every, the more, for example, the withdrawal transaction is consistent with the transaction. The withdrawal class, the as you see here, the deposit class and balance inquiry class is consistent with the transaction class, and generally the more specific classes or subclasses are consistent with the superclass. We have a principle named in object orientation. We have a principle, subprinciple. The substitutability principle states that you can substitute the more specific thing if anywhere the more general thing is expected. For example, you may define a method which have an of our superclass. In call this method, you can call this method by a parameter of type of one of its subclasses. For or as another example, when you make a list of your things, or you make your array of things, you can simply define an array of your general class, but in practice you can set some in your array to the things of or objects. For example, our cases study, we have to make a list of all transactions that have done in this ATM class. Okay. As you know, when we use an array in our programming languages such as C++ or Java language, which have a static type, not define an array of multiple types of object. You can only define an array of a single keys. For example, you can define an query, you can define another array of type deposit, you can define another array of withdrawal. But the problem is that we want transactions from to maintain or to make a representation, make a report, and so on. How you can do this problem and make a list of all transactions that have done ATM case study. We have three different types of actions. To do this, we should define an array of transaction. When we define of type transaction, in practice, you can assign or you can save some objects of type balance inquiry in this array. You can set some indexes to deposit withdrawal transaction. No problem. Okay, let me see your. Okay, no problem. When, for example, in practice, I the chat box for you, you can define an array of transactions in this way. List. You can define a new uh, array of transaction. For example, with okay, by this statement, you can define an array, a list of transaction to maintain, to record all transactions done in system. In practice, you, for example, you can set zero new deposit transaction. There is no problem because the deposit or list, you can set list one new for example, withdrawal our list can record all types of transaction. This is as problem because our list is defined as a list of transactional object of type of our subclasses is an object general type. Our general type in this case is a transaction, and our special types withdrawal, deposit, balance inquiry, and so on. Okay, so the benefit this substitutability principle is that we can make our bot in set some indexes of the list to a specific type, such as deposit, such as withdrawal, such as balance inquiry. So the substitutability principle says you can substitute the more specific thing anywhere the more general thing is expected. For example, in calling a method, you can set parameter as subtype of the can set some indexes of array to our generalization hierarchy. Generalization applies to all classifier and some other modeling elements. This is clear. There, this slide show another Example of a specialization generalization relationship. Uh, this statement said that generalization hierarchy is specializing from generalizing. This statement said that as you can figure, we have a general type shape. The general class our in this hierarchy is the shape, but this general class has three shapes, three subclasses, such as square, circle, and triangle. And we say that circle is a kind of a kind of shape, or triangle. So this is an is a relationship between subclasses and class. When we travel from subclasses, we say that we have generalization because we walk through or special types to more general type. But when we the general type to a special type, we say that we have these superclass. These subclasses are more specific elements. The general class, general elements. To see in this figure, the general parent, super base class, or ancestor. There are four different terms to announce this general class, but classes could be called as child class, subclass, or descendant. As I told you in previous slide, to substitutability principle, in can have several different shapes. Implement them. It may be needed to have how you can record a list of all your shape in the array. As you know, the array should be defined as just type of object. In this case, we can use the the menu can make we can define a list of shape, but with objects of different subclasses of the shape in the list. Inheritance is the core of the generalization or a specialization relationship in our class hierarchy. A class inheritance is implicit in a generalization relationship between classes because the subclasses inherits all features, all attributes, and met superclass. The subclass inherits the following features from its parents, include its parent attributes, variations, shapes, and constraints. All constraints over these or methods or all of this class with other classes could be inherited by all its subclasses. Okay, as you see in this class diagram, uh, class circle just has an attribute named that implies extra attributes. Okay, so altogether the class circle has 4 attributes. One of them is defined explicitly in the class circle. 3 of them inherit from the class, and also this class has 3 methods, all of its superclass. This is the same for the square. Okay, concept in overriding. What is overriding? In overriding, we make a special or a new implementation of it in our subclasses. For example, shapes where inherits the method draw from the class, but the draw method is in practice different to classes. Drawing square from a circle. It's clear for you. So to make this distinction between classes, would have specification for these subclasses, and the class square make its own implementation of the draw method, and so on for circle. The circle class circle class also make its own implementation of draw operation. The same for operation of these classes. You see the get area, the calculation area of these two shapes are different. As you know, for calculating a square, we can make length and width, but we have another formula for the of circle. So we have to make a special implementation method or special classes or in our subclass. But what is benefit of heritage case? As I told before, for you, one of the philosophies inheritance in object oriented code. The common codes make a problem in maintaining of our classes. So for solving this problem, we use an inheritance relationship. But as you see in this case study, the code of the implementation of the draw or get area is completely different from the implementation of draw and get area for circle. So what is the philosophy of this inheritance? Why this inheritance relationship is needed in this economy? This type of inheritance is not for managing the common. Obviously, the usage of this is from that we talked before. Okay. So the necessity of this inheritance is just for we can using the substitutability principle in practice. In several situations, we have to make a list of shapes, or we have to pass a shape as a parameter to a method. So we can use the principle. We make some method in practice. Those methods could be called for. Okay, so we use this design so that we can use the substitutability principle. And when we make a general class shape, some methods, this relationship make a force to redefine these methods in all of our subclasses if needed. So when we class as an abstract class, I'll define the abstract class in next slide. This improved version of these methods. Okay, I talk more about this possibility in next slides. Let me read these items. As you see, classes may add new features. It's obvious for you. Subclasses inherit features of their superclass, but other they may have some extra special features or attributes. As can inherited in operations. As I told, the draw is from shape for this class, but all of you know that the draw is different from drawing of other types of shape. So we should make a special or was class provide operation with exactly the same signature as the parent operation for draw for get area in this case study. It wishes to override because the response of these methods is different from those responsibility from other shapes such as circle signature consists of the operation name, types of parameters in order. This is clear for you. Probably there is no problem in this last statement. This last statement, operation signature. What's the different operation signature? The operation signature is consists of operation name, types of parameters, and in order, and its return uh, components make an operation signature. What is abstract operations and classes? An abstract classes are we cannot make any instances of no object could be defined of those types. But this philosophy of abstract operations and classes, not in instance of the abstract classes, why we in practice. So please note the comments in this slide about the operations and classes. An abstract operation are designed to have no implementation. For example, in shape, we define the draw method for any shape, but any types of our define its a special version of draw. So there is no needed to define any implementation in this superclass for draw method, because the draw method can from a type shape with other type of shape. Okay, this difference make necessity to left this with no implementation. There is no need to implementation in this superclass, because in practice no object of the type shape. Each shape should of any square types. Each shape should be square or circle or triangle or so ellipse or so on. In practice, we have no any object, any concrete object, so need to make any implementation for this draw method. So abstract method, we want to have no implementation in our general type shape. Okay, so abstract operations are designed to have no implementation. They serve as a placeholder. For example, they make a force developer to implement in each special class or in each sub superclass. Okay, all abstract method in relationship make it make a force a new special implement or not classes. they serve as a spaceholder. Concrete subclasses must implement all inherited abstract operations. For example, these three operations are abstract operations. So all concrete subclasses must implement these abstract operations. Okay, because the behavior of these operations is different from each subclass to others, or different class with other subclasses. An abstract class make has excuse me as one abstract view is an abstract class, because in practice we define it. But all object rating system is a type of some of these subclasses. So abstract class cannot be instantiated. We have no any instance of our abstract classes. Abstract classes define a concrete extract as a set of abstract operations that concrete subclasses must implement. We just define a framework for our subclass. We just define a format for all our subclasses by abstract class. And main this abstract class is to use a substitutability principle in practice. As Slater talks more about the abstraction level, the message Slate is that classes which stated in the same level of our hierarchy level of abstraction. For example, these two kind of vehicle has the same level of abstraction. But when we make a subclass for vehicle, as for example engine, the engine class is not in the same abstraction, because the engine is a part of a vehicle, not a vehicle. Okay? So the level of subclasses at the same level should at the same level of abstract. Another principle or another pillar of object orientation is polymorphism. As I told you in overriding concept, I told we have a draw method signature in the shape as an abstract method. All subclasses should implement own version of draw method. This is a type of using polymorphism. Poly means many, for means okay. Polymorph means many forms. Okay. All using an abstract class, then substitute classes at runtime, such as system are very flexible extent. For example, a list of all transactions from all types of transaction. When we make a list of transaction in practice, we see concrete subtype such as deposit type, such as withdrawal type, or balance inquiry type transaction could be uh, recorded in our action. Okay, so our system is flexible, has a flexible design by using polymorphism. Just add more subclasses. Encapsulation, inheritance, and polymorphism are the three pillars of object orientation, as I told you before. As I told before, and as this figure shows, the polymorphism make the possibility of all has its own implementation of the inherited operations. Okay, this level of our inheritance level of our hierarchy defines concrete subclasses, but this level defines the only abstract class of the practice, and all these are abstract methods, and they should be implemented in our subclass. This is another example for polymorphism. For example, as you see, the multiplicity this relationship is one to many. Canvas can have several shapes of several types. Some are other circle, and all of these should be maintained, should be recorded in one list, should be saved in one diagram. This is an object diagram, but this is class diagram. As you and before, objects could be referenced by the name of the class and preceded by column symbol. Okay, this uh, object diagram is a snapshot of our system when running. At this snap our list four shapes. Three of them are of type circle, and M is a square. Okay, and this, as I told you in previous lecture, this is a link between object and this circle object. This is an instance of the relationship. This is an instance of as you see in all methods and all relationship with other. As you see part of picture, this circle inherits this relationship from its superclass because this is a circle object. This is an instance of this, and see this class has no explicit relationship with canvas, but could be uh, considered for this link is this relationship between the canvas and its parent shape. Okay, so when we call the draw method of all this list of shapes, the draw method for single obviously is different. The draw method for square. The draw method is shape, but the draw method, the calling draw method for this object lead to this form of shape. Okay, so this show obviously what means polymorphism. We call this method of different objects with different results. This is polymorphism. Means many form of this execution. All of them named draw, but have different behavior. The draw method for circle draws a circle, but the draw method for square draws a square. Uh, what's concrete operation? I know we may define some operations in our general type, but in our subclasses we can implement concrete operations for that abstract operation. Polymorphism operations have more than one implementation. As I told you, this example shows in a banking system, a bank consists of accounts of several types. For example, we can define a checking account, we can define account, or we can have share account with share. It's obvious that for or excuse me, the calculate interest is different for deposit account and checking account or so we should re-implement the calculate interest each of our subtypes. But the deposit method common checking account and deposit account. So there is no need to re-implement this method in these types of it's different from depositing from share. In the shared account, we should define in deposit which owner of account make a deposit transaction. So it's obvious that the deposit method is different for shared account, other types of account. So we make a definition or implementation for this method by the type. Different classes may implement the same polymorphic abstract concrete relationship operation differently. So more allows instances of different classes to respond to the same message in different ways. This polymorphism allows instances of different classes to respond the same message. Same calculate interest is the same message for all instances of these subtypes. But the calculate interest is different for these types of accounts. For example, deposit no, okay, in all the deposit account has no interest, but checking account could interest for this type of account should return, but the calculate account for this checking account use its own formula to calculate the interest for these three types of account. So polymorphism, instances of different classes to respond to the messages, calculate interest in different ways. This calculation zero, this calculation return non-zero value, and this calculation so on. Okay, it's the generalization sets this slide talks about the generalizations, general subtypes and some subtypes or subclasses. These subgeneralization set, we could have several for example, in this figure you can see two different generalization sets. This generalization set is set of all shapes of three-dimensional shapes, and this generalization set, as you see, square, circle, and triangle, are two-dimensional shapes. So this is a generalization set, is a disjoint from this, have no class in common. Okay, so we can make by default our generalization set as incomplete and disjoint. Complete generalization set does not contain all possible members, but in our development life cycle we can end our system by adding some new classes to extend the possibility of our system. So by default, generalization sets as incomplete set and disjoints. In implementation, we have several generalization sets in a hierarchy. We can make a deeper hierarchy by our new classes. For example, when we want to implement this design as a generalization set, different one, because generalization set includes all shapes of three-dimensional shape and include all two-dimensional shapes. So we make two types such as three-dimensional shape and two-dimensional shape, which in which this class contains all operations of its subclasses, and this is so on for these three-dimensional shapes. As you see, these two-dimensional these two new generalization classes are disjoint. All subclasses of this class are different from all subclasses of this class. And this hierarchy as income generalization set, so that we can new each type. Okay. This is another example for generalization. As you know, we have several generalization for person. For example, the relationship between a male and a person, it could be defined as well as female and person class. The role of per uh, these three types subtypes of persons with the person class. For example, the role nurse in a hospital is different from the role doctor in a hospital. This is another, and this is the third generalization set. This generalization sets disjoint is disjoint or for this in this type our generalization is complete because the relations are complete. We have two gender in practice, female, and this generalization set is complete, but disjoint from generalization set. Okay. And this is the reference of our talks in this set. Uh, okay, if you have any question about this concept, please ask your questions. I strongly suggest that make your implementation of ATM case study as soon as possible, because these concepts are useful for you if you have some experience from implementing a system. If you have not that experience, all of these concepts annoying you just um, for passing your course, you should read them. But when you make any experience in implementation, you have a sense that they are needed in practice to have more powerful design, more elegant classes, and more maintainable system. So I strongly suggest that make your implementation soon, so that the extra chapters or next lectures could be useful for you. I think it's enough for tonight. If you have no any question, let me to finish the lecture. So you have no question. I'll see you. I hope I see you next session. Uh, Bye for now. Have a good night. Goodbye.